Okay, let's get started. Module 3 is all about data description. We have seen that in module 1 and 2. We learned statistics is all about collection of data, right? Organizing the data, presenting the data, and then we start analyzing the data. So here we are talking about the data description. So we'll be looking at 3 different ways to analyze the data. Okay, so in data description, there are 3 things that we'll be exploring. Let me write here. The first one is called the measure of centers. Measure of centers or measure of the central values like mean, median, and mode. That is what we do in the first part. Okay. Second part is called the measure of variation. Measure of variation. Measure of variation. And in the second one, we'll talk about things like range and standard deviation. And the third one is the measure of position. Right? Measure of positions. Here we'll be talking about quartiles, percentiles, z-scores, and things like that. Okay, today's focus will be basically on the first one. We'll complete the first one and we'll start a little bit of the second one. We'll work on measure of centers. One more time, in measure of centers, we'll be talking about mean, median, and mode. The first one is the mean or the average. Okay, the first one is the mean or the average. And you already know how we find the average. If I ask you what is average, what you'll say is, you'll definitely say that it is the sum of all values divided by the total number of values, right? That is quite famous and all of us know that. We have to find the sum and divide by the total number of observations. But besides that, in order to calculate the mean or the average, we have a few set of formulas here that you need to know. For example, if the data is ungrouped, then mean is equal to sum of x or sum of all data values divided by the total number of observations. Okay, but if the data is grouped, when we say grouped, we have the frequency there. So what you have to do is we have to find the product of frequency with the data value, add them together, and divide by the total number of observation. And the third one is a special type of mean called weighted mean. And to find the weighted mean, we use this third formula, which is sum of W times X over sum of W. One example of weighted mean is your grade point average at GPA. That's the example of weighted mean, because you have the, score from each subject, and then we take those and find the average. That's called the grade point average. So to find the grade point average at GPA, we use the weight. When I say weight here, for example, your class, this class, statistics class is 3 credit, right? Maybe your biology class is 5 credit. These are different weight of the class, right? So when you're calculating the mean of those type of thing where the weight is different, that is called the weighted mean. We are going to look at example of each of these so that this will make more sense. So here is our first example. Okay. In the first example, ages of 7 students in years in a chess club is given below. We have to find the mean, also known as average, age of the students. And here we have the data. So what you have to do is first tell me whether this data is group data or ungrouped data. What do you think? Ungrouped data, right? It's not grouped. So mean denoted by X bar is equal to, if it is ungrouped, it is sum of X over N. Okay, if it is ungrouped, it is sum of X over N. So now you have to find the sum of all these numbers. Sum of all those numbers. So that is, we have 18 plus 19 plus 17 plus 18 plus 16 plus 20 plus 18. Is that how we find the sum? And then we divide by the total number of observation. There are 7 students. Okay. Now you add all those and check. I get 126. And you divide that by 18. And if you divide 126 by 18, how much you'll get? I mean, 126 by 7, right? How much you'll get? 18. I was already saying the answer. So the average age of a student in that chess club is 18 years. Make sense? Any question on this? If you have question, let me know. The students in the virtual classroom, if you have question, unmute yourself and you can ask question. We don't have a frequency here. That means it is ungrouped. Okay. If you have the frequency given, that will be grouped. Like how many times certain number is repeating. If we see the frequency, that will be grouped. Good question. Any other question? No question. Okay. Now let's move on to next one. So this one is the group data, as you can see. Gas mileage in miles per gallon for 30 small cars are listed below. We have to find the mean gas mileage. Okay. They have given the mileage, that is your data value X. Okay, mileage is the data value, 31 miles per gallon, 36 miles per gallon, 41 miles per gallon, and 46 miles per gallon. And we have the frequency F. For example, if I need to understand this one, look at the screen. If I need to understand this piece of information, 41 miles per gallon is the mileage, and there are 2 cars that gives that mileage. Make sense? So that is the meaning of that. If I look at this 36 miles per gallon, 36 miles per gallon is the mileage, and there are 12 cars with that mileage. That is the meaning. So because we have the frequency, this is a group data. And then in group data, as I told you before, we find the mean like this. Mean is equal to sum of frequency multiplied to X divided by N. That is the formula. We have X, we have F, but we don't have F times X. So what we do is we are going to create a table of values here at the side, like this. Table of values with the given information. So I'm going to write X values here. What are those data values? 31, 36, 41, and 46. So these are the data values. Okay, these are the different data values. We also have the frequencies. So let's write the frequencies. What are the frequencies? 11, 12, 2, 5. Are we good so far? If you have a question, let me know. So what I did is I just wrote these values. Okay. X values here, frequencies are here. Now, in order to find the mean, I need F times X. So in next column, I need F times X. Remember, I told you from unit 3, we have the math, right? So you start seeing the math now. Okay. So F times X, frequency is 11 multiplied with 31. So it is 11 times 31. 11 times 31 is how much? 341. Is that right? Okay. So for the next one, it is 12 times 36. So let's do that. 12 times 36. How much is 12 multiplied to 36? 432. Very good. Next one, we have 2 times 41. 82. Okay. And then the next one is we have 5 times 46. 5 times 46 is how much? 230. So that is how you have to complete that table. So we are done with the table of values. Now let's find the total. If we add all these, 11 plus 12 plus 2 plus 5, that is equal to 30, right? N equal to 30, because if you add all frequencies, that will give you the sample size N. N is equal to 30. And here in the formula, I need sum of F times X. So these are f times x. We need the summation, sum of that. So we need to add these values, 341 plus 432 plus 82 plus 230. That is how much? 1085. Okay, great. You can check it one more time because I can see that the last digit here is 2, 2, and 1. So it should be 5,085. Okay, now you plug in the values now. So the mean is equal to, as you can see, it is the sum of f times x. Sum of f times x is 1085. And you divide by n is 30. And when you divide this, you get 36.1667 miles per gallon. So on average, the mileage given by those 30 cars is 36.1667 miles per gallon. Okay. And remember one thing, if you are writing the answer in decimal, always try to write up to 4 decimal places, unless the otherwise makes sense. Like if you are talking about money, we go up to 2 decimal places, right? Like $85.12 or something like that. But otherwise, you go up to 4 decimal places. Okay, your question. What is your question? Okay. Okay, if any one of you have a question on this one, feel free to ask now. You still have confusion? Let me know. This means the summation, Greek letter sigma. Sigma means summation. You are adding all this. That's the meaning of that. Yeah, summation. Okay, you can read summation or you can read it as sigma. That's a Greek letter sigma. You can say sigma fx or sum of f times x. Okay, so let's take one more example of the grouped data. Let's take this one here. Now you can see this group data is different compared to the first one because this one has the class. Okay, here is the question. The number of beds in a sample of 20 hospitals is shown below. We have to find the average number of beds. So this one, the first one means hospital with the number of beds between 127 and 161. There are 7 hospitals. That is the meaning of that, right? So we have the information given like that. We have to find the average. So if I draw a table and put those values here, let's see what it will look like. Let's quickly draw a table first. So I'm going to write those classes or class. We have 127 up to 161. 162 up to 196, 197 up to 231, 232 up to 266, and then 267 up to 301, right? These are the different values given. I need total here. Okay, so if you look at the data carefully, there is a F, and this is the formula for mean. Mean is equal to, mean x bar is equal to sum of f times x divided by n. So if you look at this table, everybody look at the board. If you look at this table, we have f, the frequency is given. Do you have x, the data value? We don't have it, right? We have the groups here. So what you have to do is, your x is the mid value of the class. X is the mid value of the class. And you know how to find the midpoint from chapter 2. There was an example where you have to find the midpoint. So in order to find the midpoint, what we do is, we add these two numbers and divide the sum by 2. Okay. We add the numbers and divide by 2. For example, if I add 127 and 161, it's going to be 288. And when you divide 288 by 2, it will be 144. Yes or no? 144. Similarly, if we repeat the process, 162 plus 196 divided by 2 is 179. Make sure you check it. 197 plus 231, you find the sum, and then divided by 2, it will be 214. 232 plus 266 divided by 2 is 249. And then 267 plus 301 and divide that by 2, that will be 284. So those are the X values. So if the data is given with the class like this, X will not be given to you. X is the midpoint of the class. You add the lower limit, upper limit, and divide the sum by 2. Let me write those frequencies given. Frequencies are 7, 6, 3, 3, 1. And if you add all the frequencies, that will be your N. So in this case, if you add all frequencies, that is equal to 20. So clearly you can see that you have your N that goes here in the formula. We have F and X both, but I need the product of F times X and multiply that. So in next column here, we are going to find the product and then we have to add it later on. So what we are looking for is, we are looking for F times X. So the first one is 7 times 144, which is equal to 1008. Next one, we have 6 times 179. 6 times 179 is 1074. Next one, we have 3 times 214. 3 times 214 is 642. Next one is 3 times 249. 249. 3 times 249 is 747. And finally, we have 1 times 284. That is 284, right? So once we have everything set up like this and ready on the table, all we need to do is plug in here and find that mean. So here it is going to be sum of F times X. Now we need to add these numbers. Okay, 1008, 1074, 642, 747, and 284. If you add all that, that is equal to 3755. So 3755 divided by 20. And if you do that, you get 187.75. So the average over here is 187.75. Okay. Now, if I go back to my previous example here, look at this one here. This one has the gas mileage. Gas mileage, meaning of that is the distance a vehicle will travel per gallon of fuel, right? That is the meaning of that. So with 1 gallon of fuel, some vehicle can travel 15 miles maybe. Maybe some vehicle will travel 18.3 miles, right? So decimal values are possible. So the mileage is actually a continuous variable. Make sense? In continuous variable, decimal values are possible. So here I wrote the answer using the decimal. But if I go here, in this problem, we are talking about the number of beds in a hospital. So number of beds in a hospital, is it discrete or continuous? It is discrete. They will not say that we have 200.3 hospitals. They have 200.3 bits, right? They will have 200 bits or 201 bit, right? They will not have decimal number. So this decimal number is not possible. We cannot write like this. 187.75, when you get something more than 187, that means they have 188. Okay, so you have to round this one. So you have to be careful when you write the answer, okay? Because number of bits is a discrete quantity. Discrete quantity cannot have decimal value. So you have to round it. 187.75, meaning of that is they have 188 bits. Make sure you write the unit, 188 bits. Okay, is this example clear to all of you? Yes, okay, that is perfect. So these three examples are based on grouped and ungrouped data, right? The first example was on group data. There was no frequency there. This one is on the group data because you have the frequency. And this one is also grouped because you have the frequency, okay? In third example, the difference is, in this third example, they have not given the X values directly. X values are the midpoint of the class. So we add the lower and upper limit and divide it by 2 to get those midpoints. Okay? All good? Okay, now the next one is going to be the weighted mean. I was giving you the example of the GPA, the grade point average, right? We have the example based on that. So here we have the data. Marisha completed her first semester at Community College of Aurora, and her result is shown below. We have to determine Marisha's GPA. So here we have the different subjects she has taken. We have the grades, what are the letter grades, and the credit hour. Now, if you think of GPA, what is the maximum GPA possible? 4.0, straight A 4.0, right? So that means we have different grades possible. Let me write here. They are A, B, C, D, and F. These are the different grades possible. If somebody gets straight A everywhere, GPA is 4.0, 4. If it is B, that's a 3. If it is C only, that's a 2. D is 1 and F is 0. So that is the main thing that you need to know. F is equivalent to 0, D is equivalent to 1, C is equivalent to 2, right? B is 3 and A is 4. So once you know this, it is easy for us to calculate this. For example, here we have the credit hour. Credit hour is the weight. Credit hour is the weight. Okay. So statistics is weight 4 hours here. Sociology 3 hours, 3 credit hours. Psychology 3 credit hour. Computer programming 5 credit hour. Drama is 1 credit hour. Okay. And then we have the grade. So grade is the actual data. So statistics 4, A means 4, sociology B means 3, psychology A is 4, computer programming C means 2, drama is A means 4, right? So here we want the grade point average or GPA. GPA is the weighted mean. So it is sum of X times W divided by sum of all weights. That is the formula. Let me write somewhere there. So if you look at the formula carefully, we can easily find the sum of weight. Sum of weight means I have to add all that. So let me make a table there. Let me beautify this and make a beautiful table. Just like that. Okay, there we go. Okay. So we find the total. We don't need the sum of x. You can look at the formula. We don't need the sum of x. So I don't need to add these values. You have to find the sum of w. When you add all these, what you'll get? 16, okay? 16. Now the next one we need in this column is x times w, and we have to add that. So let's find x times w. Look at the screen. So if I multiply x and w, we have 4 times 4. What is 4 times 4? 16. Next one, we have 3 times 3, 9. 4 times 3, 12. 2 times 5, and then 4 times 1 is 4. And if you add all that, what is that equal to? 51, right? Now you can see that sum of x times w is 51. And you divide that by sum of w, that's 16. And 51 divided by 16 is 3.187 approximately. But GPA, we write up to 1 decimal place, right? Like we say 2.0, right? Or 2.5. You see that some colleges will accept your application for transfer if you have a minimum of 2.5, right? So they are looking for 1 decimal place. So here, if we round it, that will be 3.2. So the GPA here is 3.2. So this is how we can calculate the grade point average or weighted mean if the information about the weight is given, because the credit hour is the actual weight there. So this is the first part of data description on the measure of centers. I told you measure of centers, we have of 3 types: mean, median, and mode. This is the first one, mean. Any questions so far? Definitely. Let me know when you're done copying it. Done. Okay. Okay, let's move on now. The next one is going to be the median. Okay. And when we say median, median is the middle point in the data array. So what you have to do is, in order to find the median, you have to arrange the data and find what goes in the middle, what is in the middle. Okay. The value that is in the middle of the arranged data, that is called the median. Okay. So let's take an example so that this will make more sense. So here we have the data given. For the following set of data, find the median. Now, because the median is the middle value in the arranged data, you have to arrange this data set from the smallest to the largest. Okay, so look at those values. You can see that we have 1, then we have 11.5, then 6, 7.2, 4, 8, 9, 10, 6. This is not arranged, right? So we need to arrange the data first. So let's do that. Arranged data values are, what is the smallest value there? 1. What is the next one? How many 2 are there? 2 of them. Here is a 2, here is a 2, right? Just that. Okay. What is the next number? 4. Next? 6, right? There is no 5. This is 11.5, right? There is 6, and then we have a 6.8. Then we have 7.2. Very good. Then we have 8. Then we have 8.3. Then 9, then we have 2 10s, right? 10, 10, and then finally we have 11.5. So first step to find the median is to arrange the data. Then check how many data values are there. For example, if you count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have a total of 13 observation. But we want to divide it into 2 parts, right? And we want to see what goes in the middle. So when you divide 13 by 2, what you'll get? 6.5, right? So you have to count 6 from this side. So 1, 2, 3, 4, 5, 6. These are the 6. And also count 6 from the other side. 1, 2, 3, 4, 5, 6. So you can see that here we have 6 data values. Here we have 6 data values. What is there in the middle? 7.2. So what is the median? Median is equal to